Hi, everyone. This video is going to discuss section 6 of the Oracle Database Programming Curriculum, which is going to involve joins. Joins are basically going to be a way to put two tables together. So if you remember, if you went through the database curriculum a little earlier, if you've gone through the Oracle Database Design Curriculum, you saw that the goal was to break things at their smallest possible parts. Such as we've done here, songs, albums, artists, platforms, things are broken down into smaller pieces. Um, but this is not the way we want our data to look eventually. We want everything to be put back together. So what we're going to be looking at here is putting these tables back together using different types of joins, which is going to be a way for us to go back and reconnect these things. Now, a lot of the stuff that we talked about already from the single table queries, stuff with functions, with where, order by, all of that stuff can apply. The big piece that we're introducing here is going to be the idea of how do we connect two tables. So the first type of join we're going to have is called a cross join. I'm going to go a little out of order here just because the cross join is not as useful, honestly. But what we would be able to do is we would be able to go in and list two table names. And what that's going to do is effectively multiply them. So if we look here, we have song. Well, let's do albums and artists. We have artists and albums. So if I were to say select star from artist cross join albums, what we would end up with is going to be what we would call like a multiplication of the tables. It's going to be every single row in the artist table. And then appended to the end of that is going to be every single album from the albums table. Now, oftentimes this is a big mess. There are rare occasions where you might need that, but the cross join is really not all that commonly used. But it can be done. It's just, if we look here, what does this tell us? Okay, that's correct. That the Beatles released Abbey Road in 1969. But the Beatles did not release 1989 and 2014. They did not release Damn in 2017, and so on. And I don't think they were on a Slim Shady LP. I'm pretty sure that was Eminem. So cross join, it has its uses. It's very rare. Typically, we would look for more of what we would call a natural join. So let's take a look at some of the natural joins. One way, and this will work if the tables have the same name for a field. It does not have to be the same in real life. It may be, but there are times where it will not be. In this case, the artist code is the name of the field in both tables. So what we're able to do is we can go in there and say using and is it artist code. I forgot in that short period of time. And if we do this, we see these three albums are indeed Beatles albums. So that is correct, and we could certainly scroll down. I would probably bump this up, especially now, because when we start to join tables, we get much bigger sets of results. We'll probably have about, I think it was 80, 60 or 80 albums, 66, I guess, is our number. But we could see Green Day, I happen to know. American Idiot is their album. Master of Puppets, I know, is Metallica. Purple Rain for Prince, and so on and so forth. So what this is going to do is this is going to connect these two tables on this field. Now, the assumption here is that that field name is going to be identical in both tables. Now, the other way that we can do this, so let me comment this out. is to specify the names of the fields. Now, sometimes you will see people shorten these. I'm not going to use aliases for tables. I'm just going to go, a straightforward fashion, but I understand why people might do that. And that's artists. So what you would be able to do is, if we look at our results here, we will see that we have an artist code, name, blah, 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 blah. And if we were to, actually, because the, what's it called? Because the using, it doesn't actually. So let's take a look. If we wanted to do it this way, assuming that tables have different names, or if you just kind of want to follow a standard that maybe your company is using, you can go in here and say something like this. Now, notice I'm saying something like this. This is going to fail, and we're going to get an error about an ambiguous column. And what that means is they don't know which artist code we're talking about, because if we join artists with albums, we see artist has a field named artist code. We see that albums also has that same field name. So how do I know the difference? The way we would do that is we have to start each of these with that name. And doing this, we should get that exact same set of results. And it does look pretty standard up top right now. So expectation here is that this would be a way for us to put these tables together. Again, using is fine, or the join on syntax would work. Now, we also have the ability to, just to point this out, you also have the ability to throw in where conditions, and everything that we've done before with those can be added there. And let's order by release year descending, so highest to lowest. So Billie Eilish, Happier Than Ever, seems to be the most recent album in our database. But again, our focus is on, if we wanted to join these two tables, we need to know what the common field is. And it has to be a field that represents the same thing. Sometimes I see students get confused because, oh, well, let's say a restaurant has a state field, and so does a customer. Well, can you join on those? Well, no, they don't. They represent different things. The state in the um, restaurant table will represent one thing. The state in the other table will represent something else. So instead, we're looking for things that are really set up to be these foreign keys. So typically, it's going to be primary key connects to foreign key. I'm not going to say it only does that. There are sometimes times where that works, but this is generally what we would expect. So let's say we wanted to do albums and songs instead. So we would look here, what is the primary key of the albums table? It's album code. We see that album code is a foreign key here. So let's take a look at how we would construct that. Now notice album code spelled identically, so we can do it either way. So let's take a look at both. And of course, you can put stuff in the select statement as well, and just select star for simplicity. So we said select star from albums, join songs using album ID, assuming that was the name. It was not. Album code. Say this way, you have to have that paperwork in front of you. And it looks like Come Together. I know that's a Beatles song. That's probably on there. Bad Blood is Taylor Swift, and 1989 is that album. Some shady LP has my name is on it. That makes sense to me. The other way to do this, instead of join using, we would use join on. It's going to be a little longer, but again, it is more versatile. So if we put this together, we're going to give this a run. And again, I'll show you. So just to show you the other way, as opposed to using the join using, join on is going to work. And we see that we get those same results. Just to show you that the order does not matter, aside from like more advanced stuff like maybe speed, there may be a reason to do it a certain way. And we can see the same results there. And likewise, reversing the tables should not do anything either. So typically what you would do is you start from the, in it like a one-to-many relationship, you would start from the one and go to the many. So I would do it this way if I were doing it, but again, it works the other way. It's just better practice to do it this way. So what if we want to also get the artist name? Well, the artist name is in a third table. So we would need to do artists join albums on artist code equals albums.artist code, or we can use the using. Now we don't need parentheses here, but I'm going to put them here just to kind of maybe, hopefully that helps clear it up a little bit. So it's going to do this join first and recreate that first query that we had done. And then that result is going to be joined on songs. Now this is going to be too much information to fit on a screen here. But we could see Beatles, Abbey Road, song come together. And let's see. I don't know that we have a lot. Well, let me just do it this way. Order by album title. And let's see if there's any repetition here. Okay, so we see three songs rather from Adele, two on the same album right there. So we could see artist is Adele. These both are on album 15, and they are different songs, but those are Adele songs. So when you join multiple tables, it's going to be very similar to what we were doing here. Primary key to foreign key to connect these two, and primary key, foreign key to connect these two. So let's say I also want to get the platform. We see platform code. We see platform code. So we could certainly throw that in as well. So what we would start with is platform join artists. And again, we can use the using or on. I'm just used to using the, on platform code. So if we wanted to join all of them, this is what the query would look like. We could throw parentheses in if we really wanted to. Let's just do it without real quick. Platforms join artists on this common field. That cluster is now joined to albums on this common field. Artist is part of this result here, so it would be part of the, it's available to be part of that join. And We saw the order by album title from earlier. Get rid of that. And there we go. So you end up with Beatles and Taylor Swift in my database, of course, not in real life, are only on Spotify versus Kendrick Lamar in this database only being on Apple Music. But what we've done is we've gone in and we've said platforms connects to artists with that primary key, foreign key connection. Artists connects to albums, again, artist code connects to artist code. And albums connects to songs, album code to album code. Now, there will be a few other options here in terms of types of queries. The ones that are going to be the most useful are going to be what they call left and right joins. So let's start with the artist join albums. So give this a quick run here. And notice, by the way, that very common oopsie has to be the same field, not another one. That would be an argument maybe for using the using. So as we do this, this is just the same query as before. What happens if we have an artist that doesn't have an album? Right now we're getting 66 rows. We run it, and I'll explain the left in a moment. But we got a 67. Witchcraft. Where did that come from? And the answer is a standard join only brings out artists who have an album in that other table. So what that means is if there's any artists who are who do not have an album, they are not going to show up in this query. So if I were to say left join, this would say find all artists from this table that match the other one and include in it any artists that don't have an album. And in this case, the only artist that doesn't have an album in my database is going to be this person, me. So what we would find is you're able to do this sort of thing. You can put this together. You can run a query, but if there's what we would call unmatched records, you would have problems. If anybody's ever dabbled in Access, probably not, but there is a specific type of a query called an unmatched records query, and that's exactly what this is. And if I really wanted to see only the artist who don't have that, we could say where album code is null, that's this column here, and you could see that Eric Cameron is the only one with a null album. So this would be the way that we would do a left join. Now, if I were to do a right join, on the other hand, remember we had 66 results before. We're still gonna, or we should, we still have 66 rows with a right join. And the reason is because each album has to have an artist, but each artist optionally can have an album. And if you remember that idea of optional versus mandatory, if it is an optional relationship, this is where that left or right join would fit in. Now, in this case, artist is on the left, album is on the right here. So when we say right join, it's going to look for unmatched records in that right table. So how can I make a right join work? At this point, it's now going to look for unmatched records in that right table, which again is now artist. I flipped the order from before. And I would still expect to see Eric Cameron just because the ordering the columns showed up in a different order. But again, that unmatched person is going to be there. All right. The other big type of join that we would look at is going to be what we call a self join. Now, I don't have a good table to demonstrate this at the moment, but let me give you an example here. So let's say we have a customer table, or let's say an employee table. This is really like a classic example. Or let me change it up a little bit. So we've got a faculty member, a teacher, professor. We've got first and last name. Let's call it chairperson ID. So if we're doing this, a faculty table that looked like this, and let me just draw a box around that and change the fill to no fill. There we are. So in this case, we would have to ask who is the chairperson. Now, it is possible that there is a separate table with chair people, but in a lot of colleges, the chairperson is a faculty member. For example, at Bergen, um, I'm teaching a computer science department course, but also in the INF department. So right now, Professor Minas is my chairperson. So in this case, he is also a faculty member. So this chairperson ID may refer back to this faculty ID. So if I were looking to do a query here, I would probably do something like, we'd have to do both tables. Let me do the from first. Now in this case, because you would be joining faculty to faculty, these need an alias. And this way you could say f1.faculty ID equals f2.chairperson ID. And if we were to do this, F2 is going to be the faculty member, F1 is going to be the supervisor. So we would say F2.first name, F2.last name, F1.first name, F1.last name, and we might want to rename that as the chair last name, and rename this one as that. And this would now be able to get us the information we're looking for. So give me a moment with the magic of AI. Let me go generate this faculty table. And I'll pick back up. I'll make this available for download so we could actually run this and see the result. So let's take a look at our faculty table that's been created to our specs. And we see that faculty ID 1, 2, 3, 4, and so on, they have no chairperson ID. And now you might immediately say, oh, well, something went wrong. Well, the assumption here is probably that they are the chair people. And if we scroll down, we can see Sophia Lynn is in computer science. Alice Wynn, faculty 001, is the chairperson of that department. So we can see all the computer science faculty, list faculty 001 as their chairperson. Next is Brian Lopez is in charge of mathematics, FAC 002. And if we find math faculty, we could see FAC 002. So let's say we want to convert this into a join, so we could also see the chair people. In this case, the table that would have the faculty members' names who do not have a chairperson ID, even though it is the same table, it's going to be the faculty F2 table. So F2, again, remember, it's kind of a reflection of itself. And if we do this right join, in addition to that original list of faculty, I think ChatGPT generated us, I think, around 72 rows. So we're at 72. Where's the rest of them? We go, should be a right join. We're up to 80 rows. If we notice up top, there's Alice Wynn and Brian Lopez. They are the chair people who do not have chairs assigned to them. So that should cover most common cases using these types of joins. We're doing, again, simple joins this week. We will look further at it next week. So hopefully this gave you some guidance, and take care.